All right, today we're diving into something really cool. It's called the CUP framework. And, it starts out as this pretty practical AI tool, but then it just explodes into this potential universal theory for, well, pretty much everything. We're going to go on a journey from simple code all the way to some big cosmic ideas. So let me just kick this off with a question for you. Imagine an AI that doesn't just spit out an answer. What if it could perfectly retrace its own thoughts? Show you exactly how it got from A to B. This whole idea, this ability to think backwards, that is the absolute core of the CUP framework. Okay, so what is it officially? The paper calls it a system of compact, invertible, and modular neural brains. Now, compact and modular, that's easy. They're small, and you can snap them together like Legos. But the real magic word here, the one you gotta remember, is invertible. What does that mean? It means you can take any answer it gives you and perfectly reverse engineer it all the way back to the question you asked. It's about total 100% transparency. Now, the first version, what they call CUP 1.0, it isn't just one thing. It's more like a family of architectures that kind of build on top of each other. You've got your basic CUP, which is super fast and lightweight. Then you can level up to CUP++, which adds this cool ability for the system to adapt its thinking based on the context. And then you get to CUP+++, and yeah, that is 4 plus signs, which brings in the heavy-duty stuff, the advanced deep learning techniques you usually only see in these giant, massive neural networks. So it's like a tiered system.
So what's the big deal? What can you actually do with this thing? Well, CUP 1.0 is basically a researcher's dream come true, especially for anyone tired of AI's biggest headache, the black box problem. You can build these perfectly transparent neural calculators. You can reconstruct exactly how a system came to a conclusion. Or you can chain a bunch of these little brains together to tackle really complex problems, and the whole time you know exactly what's going on under the hood. It's all about precision and explainability.
Okay, so far so good, right? We've got a really powerful, transparent tool. But here's where the story takes this massive turn. You have to ask, what if this wasn't just a clever tool? What if this whole concept, what if it was a fundamental blueprint for how everything works? And that question, that's what brings us to CUP 2.0. This is where the framework takes a gigantic leap. It goes from being a tool for building logical AI to a universal theory that's trying to model life, consciousness, even the process of evolution itself. It's a completely radical expansion of that original idea. Right at the heart of CUP 2.0 is this one surprisingly elegant formula. Now, I know, it might look a little intimidating at first glance, but just hang with me. The creators are proposing that this is the core equation for any complex adaptive system. So let's do this. Let's break down what each of these pieces actually means.
First up, we've got E, and that stands for expertise. The best way to think about this is like having a team of different specialists inside the system. When a new problem comes along, this E component dynamically picks the right expert or even a combo of experts for that specific job. It's all about using the right tool at the right time.
Next up is M for memory. And this is the system's ability to learn from its past and really consolidate that knowledge for the long haul. It's not just about, remembering a list of facts. It's about building a cumulative understanding from all its experiences, which is what allows it to grow and get smarter over time. Then we've got A for attention. We live in a world that's just full of noise, and any smart system needs to know what's important and what's not. This component is like a spotlight. It allows the system to dynamically focus on the most relevant bits of information and just ignore everything else. Super crucial for being efficient. Okay, R stands for logical feedback. This is basically the system's internal monologue. It's this constant feedback loop that lets it check its own work, stabilize its reasoning, and, self-correct when it messes up. This is what keeps the whole system coherent and on the right track. Now, this next one is where it gets really interesting. That symbol there is lambda, and it represents intrinsic expansion. You can think of this as the engine of evolution for the system. It's what gives it the ability to physically grow and change its own structure, kind of like how our brains form new connections when we learn something new. This is where real adaptation comes from. And finally, we have C, the constant of existence.
Now, this is the most fundamental piece of the puzzle. It's the baseline principle of stability. It's the thing that allows a system to just persist, to simply exist in the first place. You could say it's the foundation that everything else is built on. So when you put all those pieces together, the expertise, the memory, the attention, all of it, what do you actually get? Well, you get a system with some pretty incredible capabilities. For example, that memory and feedback working together, that gives you autonomous learning. That lambda, the intrinsic expansion part, that enables real neuroplasticity. As you can see here, each part of that formula we just walked through translates directly into a powerful, real-world function.
Okay, so here's the crucial point, right? If this formula really does describe the fundamentals of how complex adaptive systems work, then its applications should be, well, they should be universal. So let's zoom way out for a second and look at the real big picture here. And the potential applications are just breathtaking. Seriously, we're talking about using this for everything from simulating the adaptive behavior of a single living cell to building truly autonomous AI agents. And even, get this, modeling cosmic-scale phenomena like dark matter or the evolution of the entire universe. I mean, that is an unbelievable leap from the simple clear-box calculators we started with. The project's own summary of its ambition really says it all. They describe their goal as creating a scientific foundation to understand, simulate, and create life, consciousness, and adaptive systems. Wow. It's pretty hard to state your goal any more clearly, or more boldly than that. And through this entire grand vision, that one core principle from the very beginning never goes away: a zero black box approach. Right? Unlike so many modern AIs where the reasoning is just this opaque mess, every single thing that happens in this framework is designed to be fully traceable, fully invertible, and mathematically explainable. You can always ask why and actually get a concrete answer. So it leaves us with this huge question. Is this framework the scientific key that's finally going to unlock the secrets of consciousness and life itself? Or is it a really powerful, beautiful new mathematical language for describing complexity in our universe? You know, maybe the answer is a little bit of both. But whatever it is, it's a fascinating idea to chew on.